Merci, c'est Omar. So hello everyone. I'm Achraf BALLARI, and I was in your place just 1 year ago. I graduated from INPT last year, and as said by Sir Omar, I'm now working at Crédit Maroc as a data analyst. And today I'll be presenting to you a presentation named From Data to Decisions, Empowering Business Intelligence with Agentic AI. Basically, over the next 45 minutes, we will explore how business intelligence, which historically just reports what happened, can now decide and act autonomously using modern AI agents. So I'll take you through the evolution of BI and AI. I'll introduce you to Agentic AI, and I'll explain its architecture. Then we will finish with a live demo using a local setup. So our journey has 5 milestones. We will start by how business intelligence and AI evolved in parallel. But sadly, they evolved in separate words or silos. We will define Agentic AI. We will talk about the tools and the architecture that make Agentic AI work, and how its components integrate inside our business intelligence system. And in the end, we will do a hands-on demo with 4 notebooks. In the end, I will send Mr. Omar the GitHub link, so you can practice by your own. So let's start by the context. So business intelligence started with just paper-based reports, and slowly it evolved. So we had OLAP, OLTP cubes in the 90s. And we started building software as a service business intelligence systems in the early 2000s. Now we have cloud, we have AI enhanced analytics, but we still cannot replace data analysts. We need them in order to interpret data, and also in order to take actions. In the other hand, AI followed its own timeline. In the 90s, in the 50s, expert systems used only rule-based rules. We had machine learning in the beginning of the 2000s, deep learning in 2010. And now we have large language models. We have Agentic AI. That's the upcoming trend for 2025. So for decades, business intelligence was only descriptive, while AI was predictive. So they lived both of them in different silos. And now we are trying to bridge both of them using data and decisions. So we will know what makes exactly AI agentic. So we will define that. So the simple question is, what's exactly agentic AI? I think that you already know about AI, you know about machine learning, you know about large language models, but Agentic AI takes a step further. So it refers to AI systems that can reason, plan, and act by their own. So it's all autonomously. They can achieve a specific goal without any exterior intervention. So instead of waiting for human prompts or following if-else rules, these systems, they make decisions on their own based on contexts, data, and goals. So the heart of agentic AI is being autonomous, where we can reason. This means that the system can interpret information. It can analyze pattern and make decisions, not because a developer told it every step, but because it has learned how to think through problems. So LLMs like GPT-4, Llama, they enable this through their ability to reason with the natural language, turning complex data into understanding. What also makes agentic AI special is we can use multi-agent coordination. So instead of one monolithic AI, we can imagine a team of specialized agents, one analyzing data, another generating predictions, another monitoring. They can all collaborate in order to solve a shared problem. We can also add external knowledge because reasoning alone isn't enough. This is why we use RAG. We can use also tools. So agents aren't limited to texts only, but they can use APIs, they can use workflows, they can execute code if needed. And so this is where we have a contrast between traditional AI and agentic AI. So traditional AI was rule-based, but agentic AI now is goal-oriented. So in short, agentic AI is not just about thinking, but it's also about doing. It's about systems that know about their environment, reason by their own, and they act according to a plan. So now let's explore how these agents, they can work internally and how they can use LLMs, they can use RAG also. As we said, like in classic BI, the loop stops at only given insight. So we have raw data coming from sensors. As an example, if we are working on an industrial environment or using IoT, we can generate then reports and humans decide. But in the agentic BI, we can extend to decisions and actions. So data is collected. We have analytics and patterns as insights, and then the agent takes decision based on its own reasoning and chooses an action. This action will be executed automatically through, let's say, APIs or tools. So the loop then restarts with new data. So this closed feedback loop is the foundation of autonomous business systems. And this is where we bring intelligence into the system. So as we said, the agent on its own can be a decision framework. So it knows what further steps to take. It knows why, when to adapt, when to act. But when we pair the agent with a large language model, the agent can understand context. They can interpret data and reason dynamically. So we add context interpretation. LLMs, they enable agents to read and make sense of complex business data, like understanding that a drop in sales, as an example, in one region might be due, let's say, to a religious holiday. So this is the difference between reacting to numbers and really understanding what each part of the data means. So the second aspect of combining agents and LLMs is questioning and clarification. So traditional BI dashboards never ask you anything. They don't give feedback. They wait for you to explore. But agents can now ask back. As an example, they could ask the key user, are you sure you want to base this forecast on last year and not this year? This two-way reasoning transforms BI from being passive into an interactive conversation. And the third aspect is planning and execution. So once the agent has clarity, it moves to planning and execution. So, the LLM doesn't just report; it can suggest also actions by adjusting, by triggering. So this is what makes the agent the decision maker and not only the messenger. And in this diagram, you can see that there's a collaboration rule. So the agent sends a query to the LLM asking for reasoning or context, and then the LLM responds with the insights or recommendations. After that, the agent executes actions through tools, APIs, or dashboards, and updates the memory if we need like a history of conversation like ChatGPT. So now we've seen how LLMs and agents can collaborate, but in real business scenarios, like let's say monitoring thousands of machines or managing a multi-branch bank operation. So one agent isn't enough. We use multi-agent systems. We have specialized agents and they cooperate between them. They share data and sometimes they even compete between them if we have a global objectives. There's like three aspects of multi-agent systems. The coordination. Agents, they synchronize their goals and actions. Let's say, for example, a data agent cleans incoming sensor data, but the analysis agent, he calculates or computes KPIs, so indicators. The decision agent can then determine the next move. So this is a type of collaboration between them. They can exchange contexts, so they can act together, or like even share a mutual awareness in order to reduce redundancy or even improve accuracy. We can imagine them as different departments in one company, but sometimes they can compete with each other. Not all agents cooperate because they can be optimized for different goals. For example, a cost agent tries to minimize expenses, while service agents, he wants to maximize customer satisfaction. So the system finds in the end a type of balance between them. So now let's move now to RAG, Retrieval-Augmented Generation. Let's think about it like giving your AI system a real-time memory. So he can access to the latest data and trusted sources without retraining the entire model. So you create your own knowledge base. This is a technique used to enhance an agent's decision making by integrating external knowledge with contextual reasoning. So instead of relying on what's inside the model, we can query a knowledge base, like a simple database, a document repository, or even data sets if we want. We can retrieve relevant contexts and combine it with the reasoning of the agents in order to get a better structured or informed answer. So briefly, I'll describe to you how RAG works. So the agent or the user sends a prompt or query, and then the system searches in the knowledge base for sources like documents, structured data, and then retrieves the relevant information, the top paragraphs, metrics, or rows, and then the information is combined with the original query and sent to the LLM. So the LLM generates a contextual response, and the result is a smarter and context-aware answer. So we have some key benefits like knowledge access. Agents always have access to the latest data. Contextual relevance. Instead of a generic answer, we will have context-specific insights, more accuracy, more flexibility. So basically with RAG, our agents, let's say, are no longer guessing and relying on what they were trained on. So basically, they can answer based on a database that we created by ourselves. So let's see how these agents can use also tools. Up until now, we've said that agents can reason, can use LLMs, can use RAG, but also they can use tools and orchestration. So this is the, let's think about it like the bridge between thinking and doing. In an agentic BI system, agents, they turn insights into real operations. Like dashboards, reports, shutting down systems, adjusting operations automatically. So this is why we need more. It's how agents can talk to the external world. Your different types of softwares, CRMs, ERPs, Power BI, or ClickSense. Next is also workflow automation. So some actions, they require several steps. We can't do them in one shot. And agents, they can't run these steps manually. We need an orchestrator in order to trigger them, like N8N, Zapier, or Landgraph. Finally, we have external tools. I think that these are type of systems that are outside of the agent's native environments, like machine learning services, MLOps, SQL engines, or even robotic systems in a random factory. So the agent knows how to delegate and to whom. It might ask a data processing API, as an example, to run a query. It might also trigger a Power Automate flow to refresh a report, or even instruct an IoT controller to, let's say, shut down or slow down a production line. So this coordination is what makes the system agentic and also goal-oriented. At this point, our agents can reason, retrieve knowledge, and also act through tools. So in the next part, I'll show you some concepts, and in the end, we'll do a hands-on practice. Every agentic AI system, no matter the use case, remember, banking, logistics, marketing, IoT, it's built around three main layers. So there's the agent engine, the orchestration layer, and the tool layer. These layers communicate through a continuous data flow. This is how we transform data and information into automated actions. The agent engine is the brain of the system. It's where it's powered, by the way, by the LLM, and it's where the reasoning happen. And the orchestration layer. So once the brain decides, it needs coordination, like the nerve system. Imagine having multiple agents, one watching the sensors, one predicting machine failure, and one taking preventive action. The orchestration layer makes sure they talk to each other in the right order and at the right time. And also we have the tool layer. Finally, the system needs hands. We already had the brain, we have the nerves, now we need hands. That's the tool layer. It's where the reasoning turns into actions, API integrations, external system interactions, action execution. So this is what gets things done. And now that you understand how these three layers can work together, let's see how they connect a full business intelligence system. So here we are. This is the full picture. The diagram shows how Agentic AI connects with business intelligence to create a continuous autonomous decision-making loop. If you remember, our three layers have, from the previous slide, the agent engine, the orchestration, and the tool layer. They now merge directly with the BI stack. We start by data sources, including IoT sensors, different softwares, different databases. Then the data flows into the analytics and machine learning models. So here we need to move from raw data and raw numbers into insights with the meaning. The agent engine comes next. It's bringing So it does not just it does not just repeat the prediction. It can interpret and reason about it and decide. As an example, like should we pause production or is this anomaly within tolerance? So this is a decision-making brain. Then the orchestration layer, they manage how everything interacts. And finally, we reach the two layer. This is where the decision becomes action. So from top to bottom, the process looks like this: data sources, analytics, the agent engine, and then the two layer. The system then can monitor the outcome, learns from feedback, and then the loop continues. Whenever we get feedback, we start from the agent engine in order to fine-tune our answers next time. So we will use now a hands-on practice. As I said in the beginning, I will send Mr. Omar Souissi the GitHub link in the end in order for you guys to work by yourselves. We will do a streaming simulation. We'll use also an agent and drag, and just telling you guys it's all run locally. So I will stop sharing the screen now and I'll be back in about 30 seconds. Give me 30 seconds, guys. Can you confirm, guys, that you can see my screen? Okay, so I used a public data set called the AI for AI 2020. It's a data set about manufacturing. We have, as you can see, I'll run the code and we'll go through everything. So there's different columns. We will not need them all. We'll need just 5, and we'll keep only 5. We'll keep the air temperature, the process temperature, the rotational speed, and the torque, tool wear, and our outcome, if the machine will fail or not. So basically, we will use MQTT as our protocol in order to send the data. I chose it because it's lightweight and we don't have a lot of packets to send. That's why I didn't use REST or another protocol. So I'll run it. I guess you cannot see the screen. I think you cannot. So give me a moment, guys. I think this is better. So this is just a simple example using MQTT in order to publish data using a lightweight protocol. In our use case, we will try to make the agents make decisions based on these 5 columns. So we'll need to start. as our baseline, we will use a machine learning outcome. So we will compare if the agent and the machine learning model, they got the same output. No. I don't know why it's not working. It happens all the time. This is now better. So we added a new column to determine if the machine will fail or not using random forest, I think. But this is not our goal. Our goal is to make the agent make the decision. So that's what we're trying to do. And don't worry, I will clean this Jupyter notebook. I didn't just have the time. I just got off work 1 hour ago. So this is what's interesting for you. So here we run a local agent using Ollama. So basically, Ollama is our interpreter where we can run LLMs locally. You can download it; it's free, or you can use a Docker version. They work the same. We will use also a Llama 3 model, as shown here. I already downloaded the 3 models, MX for embedding, Llama as kind of small model, and DeepSeek is a large model. It needs a lot of computing power in order to answer prompts and give responses. That's why I don't use it a lot. And if you want to download or pull any type of LLM, you need just to write Ollama pull and then add a model from Hugging Face. You can choose the right model for you, depending. Let's say if you want a model for text generation, you can pick one of these. It's up to you. This is our prompts. Explain in one sentence what an agentic AI system does. It will take some time. It takes about 100 seconds each time. But in my recent paper, I did optimize the results to be sub 10 seconds. So this, when you can get an agent to give you answers in less than 10 seconds, we can consider it real time. The norms for IoT and industrial seconds are below 10 seconds. So when my research paper comes out, Mr. Souissi will give you the link. And if you have any answers, you can contact me on LinkedIn or using my email, and we can discuss about it. So we will wait now just for the answer in order to show you that it works really. And it's free, so you don't need to pay for any tokens in Claude or GPT. You can, let's say, you can spend some time in order to create a personal assistant in your laptop. It can do research for you. it can do your, I don't know, your homework even if you want to. So this is the output finally. This is the answer, and this is the time in order to get the result. It's not optimal, but for the sake of this presentation, you can use smaller models in order to get faster answers. So now we will compare the machine learning baseline with our agents in order to determine if our agent by its own can give, let's say, give the right answers. So we gave the agents our 5 columns, and using MQTT as a subscriber, this is the prompts. So we said to the agent that he is an industrial safety agent. He can use the machine learning results and also the sensor data in order to decide if the production should continue or pause. And we're gonna run it as we did in the beginning. So we have our 5 columns that we took from the data set, and we're trying to simulate as incoming data from sensors. We have the machine learning prediction, and we have the agent response, and then the response time. It's gonna be also 100 seconds, I'm sure. But as I said, guys, you can amuse yourselves by trying to improve and optimize the models. So we have 3 ways in order to get better answers and better response times. The first one is to fine-tune the model. I'm using the basic model, so it has the whole information that the model was trained on, and this is not optimal for me because I'm running it locally, and I need only a small model. The second way is prompt engineering. Instead of giving the agents a direct prompt, we can give it contexts. We can also explain our use case. And then the third way we can use to optimize our response is using RAG. And this is what I'm going to show you next. I'm going to push the agent to use only the knowledge base that I gave it access to. Even if the answer is wrong, it will respond with the wrong answer. So we will wait just for a response now, and we'll move to the RAG application. So this is the machine learning prediction. We have no failure, but the agents decided to pause the production. And this is the opposite of the machine learning. So we know that the agent couldn't give the better answer. So now we will see the use case of RAG. So basically, I made a local file as a markdown where the capital of Morocco is Madrid. We already know that this is wrong, but using a knowledge base, we can tell the agents that he is a retrieval-augmented assistant, and he must always answer using only provided data sources from the markdown file. Even if it contains errors, it should return the answer, and this is what's gonna happen. So instead of keeping the markdown file as text, we had to embed it first and then tokenize it in order to make the agents understand how to retrieve the necessary data. Because we have for our example here only one file, we don't need to use chunking or the top K retrieval to retrieve only relevant documents. It's not the case. So it's a simpler use case. In your academic research, you can use this to have a bunch of, let's say, documents, articles, I don't know, presentations, and you can create your own agentic AI system locally that can extract only the important data. So if you don't want to read the full 60 or 70 pages, you can go straight to the point using this simple RAG agentic AI. Sadly, we have to wait another 144 seconds in order to get the answer. But this is gonna be the last part, so bear with me. So we don't need like top sources because we have only one markdown file. And this is the answer. According to countries and capitals at the file, the capital of Morocco is Madrid. Even if it's false, we push the AI agent to answer according only to our knowledge base. So let's say that you're working in a car factory and you want to implement a agentic AI system using LLM, and you're asking it about wheels. It can answer about like plane wheels, motorcycle wheels. But if you tell it that you have your own knowledge base about cars, it will answer only about the specific knowledge base that you have. So, and this is all, guys. If you have any quick questions, they are more than welcome. And if you need anything, you can contact me in LinkedIn. It's Achraf BALLARI. And in the end of the presentation, you'll find my academic email where we can exchange about agentic AI. It's a new submergence subject, so there's not a lot of even research articles out yet. and also tutorials from YouTube are not detailed. I'm starting to use N8N locally using Docker. I'll add in my GitHub also a tutorial how to install everything. It's more user-friendly and it has more tools. You can use Google Drive, SharePoint, any type of external databases, SQL, Postgres, anything. So that's it, guys. I hope that you enjoyed the presentations. And if you have any question, feel free.